Good evening and thank you all for joining us today. This session will run over next 60 minutes including Q&A. The session will be recorded and will be uploaded to our Reactor YouTube channel. We will share the link to our YouTube channel in the chat section soon. Before we begin, please take a moment to read our code of conduct. We are all here to learn together, so be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout and we will encourage you all to participate. Also keep your mics muted during the session. I would like to welcome Shivam, our speaker for today's session. Shivam is an author, a cloud architect, speaker, and co-founder at TechScalable. Being passionate about ever evolving technology, he works on Azure, GCP, machine learning, and blockchain. He is also a Microsoft certified trainer. As of now, I hand it over to Shivam.
Thank you, Parth. Let me share my screen. Okay, so welcome everyone. Hopefully you all are well, you all are safe as well. So check this out. Let me quickly explain the agenda for the day. Now, today's session is slightly different from the sessions which I generally, which I usually do. So today we are going to use machine learning in a very interesting way to classify the images which are coming from the space, from the data which we have collected from the various data sets provided by NASA itself and from other locations. So we will be talking about how to classify these space rocks. And this session is very interesting as such. I'm pretty excited for this session. It's different from the usual ones. And just to uh, just to show you a couple of things, on this landing page, you will find the learning module link. I will walk you through the learning module link in some time. I'll take you to that, and whatever we will do, whatever we will cover, everything is available on that on this page over here, from where you can you can cover all these things in more structured step-by-step manner as well. Right. So we'll go through this in maybe in next 15 to 20 minutes. But before that, let's go and uh, admire a couple of pictures which I collected from various NASA websites and various missions which they have done uh, as such. So which I have kept over here. And there is a small uh, journey which I will take you on with me while explaining what we are supposed to do. So these images are from NASA's website itself. And if you can see, in this in this image, the astronaut is right now on moon itself, and it's uh, it's a real image. And if you can see over here, this is the structure of this is the surface of moon, a close up of the surface of moon over here. Now, if I just want to take you or want to explain a couple of interesting use cases which we have in the field of AI, or if I just put it straightforward in a straightforward manner, how machine learning or how AI helps in the space exploration or helps in the various parts of the space exploration programs. So over here, if you think about this astronaut as such, right? So if from their point of view, so as you already know that astronauts, there are a lot of footage also available. You can look up for the footage as well on any of the video indexing website about the space walks which they do, right? So the astronauts, they engage in they come out of the space station and they basically have to repair various modules. They have to install modules and so on and so forth. So if you check this the suit which they have, I just want to show you a couple of things. You look at this. This is the outer surface of the glove which this astronaut is wearing right now over there. Now, this this glove is made of 5 layers. There are 5 layers over there. The outer layer is this layer which is made out of rubber, and this is the layer which is supposed to be taking all the hits, because when you repair stuff even on earth, right, if you practically think it through, if you wear any let's say if you are wearing any type of industrial glove and you are doing some heavy repair or lifting or something, there are so many sharp edges over here, so many corners will be there, and definitely your gloves will get damaged because of that. Now this damage is very scary or risky for astronauts, because the glove is having 5 layers. The top layer is of rubber. The next layer is of this material which is called as uh, Vectran as such. This is a very highly cut resistant material. So this makes the second layer. So when the cut or the wear and tear, it reaches the second layer, it becomes very you can say the situation becomes very risky, because after the second layer, the next 3 layers which are there, they contain the the systems which keep the spacesuit pressurized and maintain the temperature as well. So if something happens to this layer, or the layer which is after the third one, then it's literally a life threatening situation there. So as a standard procedure, or as a standard practice, the astronauts, they take pictures of the gloves before and after, whenever they have to wear it. Before and after, they take the pictures as such. Now these pictures which they take, these pictures are sent to the if I can just show that, these pictures are sent to the you can say experts which are sitting on earth, and visualize the they have a look at this, they analyze the damage, they understand what's going on, where there is a cut, where there is a nick, or how much wear and tear has happened on the gloves. So there is a the team of experts, they take care of it. Now, so maybe because the space station is right now, like, versus if you practically think it through, like versus any other, like, this is the image of Mars over here. So this is an image of Mars right now, and this in so practically think it through. The space station is so near to the Earth versus Moon or versus Mars. So if if for every single task, if the request has to go to the you can say support team which is on planet Earth, then it will take so much of time. Just for your information, just to send the signal to Mars and just to send the signal, it takes 20 minutes, approximately around 20 minutes. So if the round trip will be of 40 minutes. So if you send any signal, it goes and comes back in 40 minutes. So if something goes wrong, like maybe if you are moving any rover over there which is collecting some you can say rock samples and so on and so forth, then you will come to know after 20 minutes that something went wrong over there. So what we need to do is we need to do the AI, but on the edge itself. Like, if is it possible that can't we just have these AI systems deployed in the edge? The edge being right now being the extreme space itself. The edge is right now space in this example. So they have already done that actually. Uh, so just to show you a couple of pictures, what Microsoft did, Microsoft and NASA in collaboration with HPE as such. What they did, they trained an application. It's a computer vision application, and they have already deployed that application in the space station. So the application is deployed in these computers which are made by HPE, and these servers are called as space-borne computers too, and and so on and so forth. Now, this is how they look like. I was able to find two pictures of them. So these are those from two different angles. Now, an FYI, this image is of the ceiling inside the space station, because there is no it's weightlessness there, right? So you can put things in the ceiling also. So that's what they have done. So the AI systems which are the computer vision AI applications is right now deployed in these servers over there in the space station. And what they do, and that's what they are doing over here, real time tracking of the wear and tear which is happening in the gloves. So this image is from their website. So NASA glove real time tracker, Microsoft Azure Space, deployed to the HPE partnership. It's basically the server, the supercomputer is there in the space station itself. This is just an example of how useful AI and how useful machine learning will be there for the purpose of space exploration. And this is just from the point of view of safety from a very small the to find the wear and tear in the gloves as such. Now, apart from this, uh, if we practically think it through, and also before I go in more depth, can someone let me know in the chat window what is this image of? What is this? It was a few months back, this image was very popular, right? In all the news channels, you must have seen this image and you must have read about this asteroid. Anybody knows which asteroid is this? UFO. So this is the asteroid from where they have sent the mission to collect the Osiris Rex was the name of the mission, and they have sent the mission to collect the rock sample from this asteroid, and the mission has already collected the rock samples and it's on the way back to planet Earth. Uh, that's what they're doing. The name of this asteroid is called as uh, Bennu. So the Bennu is basically, and why have they done it? Because Bennu is one of the asteroid which orbits which can unfold the mysteries of how the solar system was how the solar system came into existence, what was the initial chemical composition of the solar system, what type of like is Earth something which is based on the chemical composition? Is it something which is unique, or is it something which is not that unique and we may have more that type of composition is pretty, you can say, normal in the solar system and beyond. So this is the image of venue, and they have already collected the samples from this. So what they did, this is the close-up image which I found from NASA's website. So the Osiris Rex mission, went and it picked up the rock samples from there. So this brings to the discussion which we are going to have today. Like if you look at this image itself, you will see that there are some dark areas over here and the lighting problem might be there, and so on and so forth. So this is like the autonomous vehicle basically went and sort of picked up the rock samples. Similarly, if we think about we can say, if we think about the moon example from where we started, even if you think it through, right, from their point of view, the the time which they can spend on the surface collecting the sample will be very less, because there is so much of complication based on the life support system as well. And apart from that, even if the autonomous vehicle is there, you cannot drive the autonomous vehicle from Earth on Mars, because it will take so much of turnaround time. So you also need some sort of local system over there which can take care of it, while you can remotely give the commands for the local system to act. So those type of autonomous systems will rely a lot on the computer vision, or will rely on the feed coming from the camera, and on top of that it needs to be done. So if I take you to that landing page before, which I was showing you, so if you open this link over here, on this link over here, we basically, you will find that these are the various modules. So there are a lot of modules over here, a lot of individual steps, like why do we do these space rock analysis, why should we do that, what's the point behind it, what are the things which we have already done, what are the new frontiers which various agencies like NASA is right now trying to you can say win, or maybe achieve, or reach out to, and so on and so forth. And then how machine learning helps in all of this. So basically, I have kept a couple of pages open over here, the ones which I want to walk through right now. And then I also encourage you to open this learning module from here, and then you can simply log in from the top, and you can using any of your email IDs, and you can even go through these modules. You can save the progress and so on and so forth. So if I show you the ones which I have opened, so check this out. Now, either an autonomous vehicle collects the rock samples, or maybe any human being does it. There are challenges in doing so, right? So some of the challenges are mentioned over here, but these challenges are just from the point of view of what happens over moon. The challenges what will happen beyond, you can say, on Mars and so on and so forth, will further be more complicated over there, right? So on Moon, just FYI, pretty interesting information, right? This is something which we regularly, or we in our field, we may not engage in all of this. So on Moon, there are various type of rocks which are found. So we have this basalt rock and highland rock. Basalt rock is the one which is dark in color. The highland one is the lighter one, the white ones as such. The highland ones are the ones which create the crust of the Moon. And it's the scientists, they think that because of the volcanic eruptions on Moon, the magma which came out as such, was when it was getting colder, that condensation, when that happened, or when it became, you can say, from the molten state to the solid state, because these were the lighter rocks, they came to the surface, so they make the crust of the Moon. And the basalt are the other ones which are the darker ones, and which are generally below the crust over there. We also have regolith. Regolith is a so whenever the rock is broken by colliding objects, then regolith is that type of rock. It is made up of broken rock and soil. Now, apart from this, they also have other type of rocks which are like when you break something, and the rocks which are broken and then combined together. And so we have those type of breccia as well. These are combination of rocks which are smashed together. All of this. Now, so these are some of the pictures which is available from given provided by NASA as such on this. It's all on that learning page over there. So this is how the basalt rock looks like. Now there are a couple of interesting points which is brought to us in this learning module. One of the important point is, like, from the point of view of any human being. Imagine you're walking on the surface of Moon, right? Just we can imagine, right? So now so there are so many black rocks, the basalt ones. Now, out of those, there are few of the white color ones, the highland one. So what will happen? Uh, the human tendency, the tendency of any human being, or the human tendency is that you will pick up the shiny ones, or you will pick up the white ones. So, but which may not give the color, which may not give the correct understanding of the population, or which may not give the correct understanding of the chemical composition of that surface, because you have only picked up one of them. So so NASA says that we generally pick up, like we also pick up the unique rocks, but we also pick up the ones which are more common over there. So if we pick up 10 sample of the common ones, we pick up one of the unique sample, just to see the difference over there. So this is how the basalt rocks looks like. This is how the highland rock looks like. And uh, and this is where they have this is one image which they have taken over there. Now, if I just take you further over there, so this is, I think, yeah, some other images are here. Now here there is one question: what type of rock this looks like to be? So this is basically the basalt rock. So as human beings, we can maybe we can compare this with the previous ones over here. We can say think that the size and the color combination and the structure, the texture, the cut, the edges, and looking at all of that, human beings can extract those features and maybe classify the rocks accordingly. And the tricky part will be the lighting conditions. Maybe there is a flash which is in the image, which is shining on the image, so the lighting is different for that. Maybe see some extra things are also there over here. These extra things, the background is white right now. So if you're doing any machine learning, you have to crop out the rock from the background, and so on and so forth. All those things uh, will also become as part of the data processing. Now, this is where so if you open that link, you will find the link for the Oasis Rex Osiris Rex mission, and I have the link open over here. So there is a particular timeline. Just FYI, the rock sample is already collected, and it's on the way back. It will be on the way back to Earth. I think there is a particular module which was supposed to be. I remember from it was in the news a few months back that the module, there is a disk which is having the rock sample, will be ejected from the rest of the system, and it will supposed to travel towards Earth. So that part will happen. Okay, now if I take you back, so now at the end of the day, it comes to image analysis, and images are not that difficult to work with, or you can say, or if you work in machine learning, space might be new for you, but images are not that new. Uh, as such. So this is one image of Abraham Lincoln that I have here. And if you can see, the images are basically made up of the pixel intensities. So these are the pixels over here, which represent these images. So the learning, all these links which I am showing, I am showing from this page. I'll just put this in the chat window. So all of that is from that one. It's in the It was in the chat. It's also going in the chat now, right? I have just opened all these links there. It's from that same page. Okay, so now what we are going to do is we there is a so when we talk about image analysis, we have one type of algorithm, or one type of process, which is, or one type of you can say, deep learning model, which is called as convolutional neural network. So that's what we are thinking of using in this scenario as well. So what we are doing is, if you think about convolutional neural network, you see this input, the blue image over there, the input feature map right now, and that gray 3x3 gray, you can say, filter is right now doing the convolutions on top of the input over there, and the output is this green part over here, which is coming up after the metric multiplication, or the metric addition and multiplication, and then the addition of the outputs. So this is coming up over there. So this operation of this filter just moving on top of the input feature map is the convolutions which are going to happen now. So if I further take you forth, like if you think about human beings, if you have to identify any, if I give you any superbike to identify, this is how you can do it. You may be looking at the color combination, the edges, the patterns, the maybe the circular patterns over there, in terms of rock, the texture of the rock, right? Size of rock and orientation of the size and the shape of the minerals. In terms of a sport bike, maybe we will look at the wheel structure. We'll look at the spoke, the pattern in the spokes over here. We will look at the height of the back seat over there, or we will look at the engine, and whether the engine is having the cover on top of it or not, and so on and so forth. These type of things are there, which are basically what you can do to extract the features from the input image. And similarly, the algorithms which we have, they move these kernels on top of the input images and the intermediate you can say feature maps to find the to extract the features on top of it, and then we do the classification on top of it. So if we pick up this same example, this is one very, you can say, enthusiastic representation of the neural network and some connections which are there. And this is basically how the convolutional neural network will be looking like. In the input images are there. Those convolution operations are going on again and again and again and again. And then we are doing some other pooling operations, and then we are getting finally the outputs over there. So the data which we have collected, the data has been collected from NASA itself. I'll put this link in the chat. This is one. This is another separate link which I have opened. The link for the data which we are using in the example is already there in the learning module, but this link is another extra link. This is like the parent link from where the data has been gathered. So you can go to this page and you can simply look for the for the various missions over here. What type of rock are you thinking of, which you want the images as such, and you can go for the search operation over there. And then I think it's already open here for you guys. Okay, so I'll just show you one extra thing here then. Maybe something like that. Okay, so once you do the search, it looks something like this. You will find the all the labels accordingly. You will find all the features as well, all any metadata about this data. So the mission, the bag number when it was extracted, the origin, weight, the type of rock which is there. So this is something by which you can create your labeled data set, and the any subtype of the rock, and any other information about the rock, and the images are there on the are also here. These are the various images over here, right? And on the other page, you can also find some other type of images as well. So you can search by the mission and the rock, or you can do image search also there, right? So finally, what we have done, we have our data. We got the data. Data will be there in the learning module itself. You don't have to look on this website for the data, but this is just for your FYI, for your information, that in future, if you are planning something ahead, you can use this for your, you can make your own data set. Now, so what I have done is I'll take you to my Azure portal. This is now you are in the usual territory of Azure, right? Normal machine learning and so on and so forth. But it is applied on the extreme edges as such. So this is how Azure looks like. This is one of my demo accounts. I have created one machine learning service over there. And machine learning service of Azure is one of the custom AI solution, one of the primary custom AI solution by which they can create custom AI. That's what we are doing. Rock sample. Are we also going to use Azure Cognitive Services? No, not really. The amount of data processing which we are doing, or the amount of flexibility which custom AI will give us, is why we are using the custom AI as such. Cognitive services are amazing as well, right? Okay, so now I have created this AML reactor and so on and so forth. It's in ECS right now. I have just clicked on it and it's launched. So this is how the interface of the custom AI solution looks like. We have various options on the left hand side. Notebooks are there. The notebooks are the ones where we write the code. The auto ML is here, automated machine learning. Designer is an UI, and from that UI you can drag and drop and create stuff. Data set is is representing your data, file data, or tabular data. Experiment is where everything is logged under. The logging happens under one experiment. The pipelines, tomorrow's topic, it will be pipelines and machine learning pipelines. These are not, this is not exactly MLOps pipeline. We'll differentiate between them. So join me for tomorrow's session as well on MLOps. I'll skip this for now. Environments are simply environments, like PyTorch is what we are using. TensorFlow is another environment, and so on and so forth. So you may create your own environment, so you can keep it. Trained models can be saved over here. Endpoints are the when you deploy any model, as in let's say you deployed it somewhere. So that API endpoint is what will be listed here. Now compute is what I have created. I'll just show you that. Data store simply means the original locations where the data will be there, like data lakes. Link services are for connectivities to other services in Azure. And when you don't have labeled data, you can also start a data labeling project. You can invite internal, you can say contractors, you can hire contractors, and you can give the links to those contractors, and they can definitely they will charge you something. It's not part of Microsoft Azure, but you can find your own internal team members, and maybe some you can hire people, and you can create these data labeling projects as part of this data labeling section. I have clicked on the compute part, and this is my GPU machine over here. which is running. Other things are also there. You can look up. This is one of the third. I think the 30th session today. So in the last 30 sessions, we have covered all these things many times. So you can look up for the other things over there. Now this is my compute instance which I have created. This basically is named some default name is there, and it is having GPUs right now. And so the GPU which I'm using is one of the old ones. K80 is old, and the new ones are also there. The recent ones are also there, but in my demo account they were not available without they were not freely available without they were not free of cost in my demo account. So I went with the K80 GPU. So this is already running. Now if I take you back, if I click on the notebooks over here, I can use this interface as well for my development. And that's the Jupyter Notebook. That's the data zip file which is available in the learning module, which I extracted over here. And if you like this interface, you can use this interface, or we can do one more thing. We can just go one page back. You can use Jupyter Lab, Jupyter, VS Code, RStudio, Terminal, and Notebook is that same thing. Terminal is just for your maybe some terminal jobs. Now, if I click on this Jupyter, it opens the usual Jupyter Notebook. So it sounds very, you can say, over here. This is my Jupyter Notebook, and it's basically running in that GPU machine which I just showed you. And I have it's the same things are there. If I show you the data, there are two classes which we are using right now in this example: basalt and the highland rocks, right? So if I click on any one of them, I should be able to show you the images as well. So the image is pretty big, but this is one of the image, and you can right. So these are the images over here which we are using, like that. So now, okay, so if I take you back, that's the Jupyter Notebook. It's open over here. Now let's go through the code as well. Now we are using transfer learning. There is a ResNet 50 neural network which we are using, and then we will just train the couple of last layers for on our data. Rest we will use the pre-trained model as such. You can train the model entirely from scratch. It will just take some time for you to do that. Now, if I walk you through this, we are going to use PyTorch, and you can use TensorFlow as well, but PyTorch is what we are using right now, and Torch Vision, and Matplotlib for some plots as such, and Pill for the visualization of data, and NumPy for the metric multiplications. And we want the images to look slightly better, so we are just looking for the high resolution images. So we are specifying that. You can unzip the data. The In Azure machine learning, the module should be there. Now we are simply doing a transformation on the training data set and the testing data set. The images are, you can say, are being cropped over here. They are being resized, and they are getting converted to tensors. And then we are just setting two variables for the path of the training and the test data set, and then the length of the training folder as such. And it's just one minus from the entire length of it. So we can uh, the indexing starts from 0. So one minus over there. Now we are splitting the data 80-20%, and we are finding the image which represent the 20% of the data, and then we split from that image, and finally that split is being created. And then there is a we do a sampling of the data, which basically, so in PyTorch there are two things: we have data sets and we have data loaders. Data sets basically are representing your data, and the data loaders are the wrappers or the iterators which will load your data based on your need. So we are using batch size of 16 right now. You can play with all these values, and the data loaders are there, one training and one for testing purpose. After this, we uh, basically are just getting some random images over there, and we are printing out we are plotting these, we are displaying these random images right now. So these are some images which we are using. I actually have CPU, I have GPU available. So we can use GPU. Otherwise, you can use CPU as well. We are using ResNet 50. It's one of the pre-trained. It's ResNet is residual networks are there. You can look up in their research paper what is this. I have previously done one session on transformers where we were discussing about the residual connections in the transformers as such. So it will be simpler. It will be, you can, if you go through that session, you will get the logic behind the residual connection. Now we are simply, you can say, adding few extra layers over there for our model training. And the model is basically, the device is the GPU for us. We are These are hyperparameters. You can change them. There is no rule of thumb right now. We are starting with five epochs over there, and then we do the model training. So these are the model, the epochs, and we're just printing it out after every uh, 5 steps. And the accuracy which we are able to achieve on the rock data was 0.96. And we are saving the model over here for PyTorch .pth or .pt. And once we have done that, we can also, you can say, do the we can check it out whether it's doing, how is it working. So this is the testing which we have done on few of the images to see, is it of, you can say, of which type of rock. Now, can ResNet 50 classify a rock? Answer is no, ResNet 50 cannot classify a rock. You have to do transfer learning to train the ResNet 50 on your own data set. So transfer learning is what we are using. So transfer learning basically means use any existing pre-trained neural network and add few layers in the end, and then train those parameters over there, train those weights for your data set. So then it will can work on the on uh, on rock data set. So whatever we have done over here, this is this is the same thing which is mentioned, or all the things which I have just showed you. All these things are on this page, where it is divided into one, two, three, four different modules. And all the things which I have shown will be having in-depth step-by-step explanation as well. Like for example, if I click on one of them, maybe like what was done, and so on and so forth, why was it done, and the entire steps surrounding that over there. So think it through. This is what we planned for this session. Let me take your questions as such, and let me go through it. Okay, in the chat, why ResNet 50? There is no, you can try other models as well. This is one of the one which is picked up. Try others. There is no hard logic around it, why it was used. Okay, so right, so if we think about what other look things are there, what other frontiers are there where AI is used in the cloud, in the space exploration. So it's used in like, I'm pretty sure you already are aware of it, right? Microsoft did a tie-up with SpaceX for the, so Microsoft created those mobile data centers and they are using Starlink. So they have a tie-up with SpaceX and they are doing things with them as well. So the in the satellite communication, in the space exploration with NASA and with various other partners which they have as such, they are using there is a concept called as Azure Space, literally Azure Space, orbital space like that. And as part of it, various things are being done in the using Azure cloud. There is one question in the chat saying, uh, can ResNet 50 is doing this job as rocks is not under the classification categories. We are The rock is not under the classification category. We are training a supervised learning. We have two categories over there. We are training for basalt and highland. So we are doing a supervised training right now. And then we have specified that there are two categories, two labels are there, the basalt and the highland, two labels. You can unmute and you can ask your questions as well.
Hi, okay. Am I audible? Shivam?
Yes, yes.
Yeah, thank you, Shivam. It is really good and informative. So just one question, if I have Visual Studio 10,000 rupees subscription, yep, that comes as a subscription, can I implement this project and run for a couple of days, or it will cost more? If, any
The
suggestion, any view on that?
so now I think the subscription which you have, the 10,000 one, that is basically the developer support one, I think. It took me this project which I just showed you. This one took me, I think, 45 minutes to set up and train. So and training was as part of that, but one part of that was because of the GPU as well. I was using GPU. Maybe you can add 5, 10 extra minutes for CPU. Data is not that huge. You definitely can do it in that. And for others who are thinking of how we can do this, you can go for Azure trial subscription. And this is the one which you can use over here for the trial purpose.
Thank you. Thank you.
Right? Okay. Okay, so questions, please, guys. Think it through. Open your creatively think it through. Which other areas do you think or where the AI can be used in the space exploration? One thing which there is one session which is coming, and we will be using some of the images of the James Webb uh, telescope as such. The one which was recently launched, but the images are not yet available. So Hubble images is what we will think, but from James Webb point of view, it's classification of you can say galaxies as such, clearing out the images. They are very interesting companies are based out of Bangalore, India itself, who are working in the space sector, and we can think of those scenarios. Do share anything which you may have seen before or worked on before. How to create the endpoint for this model. Now, this model has to be deployed first. This model is not yet deployed, so we have to deploy that. Tomorrow we have a session on the ML ops, so we will be deploying it. Do join me for that. Now, basically, if I just show you this, uh, let's say the type of deployments which I can do with this is I'll use my whiteboard. I can explain it uh, right away. Check this out, and we'll be doing it in the session tomorrow, right? So do join me for that. So basically, there are two things which can come to your mind. If you have, let's say, if you have already an existing microservice architecture deployed and running somewhere, maybe in one Kubernetes cluster. So, okay. So let me do one thing. Let me open another window here. It's not moving around. It became very, yeah, okay. So check this out. So when you talk about the model endpoints, there are a couple of things. So the model which we have trained, we will be saving it first. It's not even saved yet. So once we save it, the model will be saved in the model registry, which is part of the machine learning service itself. It's called as models over there, where we can version it and so on and so forth. So let's say we save it first. So when we save it, versioning will be there and the tagging of the models will be there, like any metadata about the model. So the next step which we have to do is this model needs to be, you can say, pulled into an or one image needs to be created with this model. So when you create this image, we have to specify the Docker file over there. Now, Docker file need not be created as it is. This is being replaced by the environment files. So if you because the environment files will already be having the the environment used to train the model, those environments file can be used, and when the Docker image is created, the environment will get installed or the libraries will get installed. So we need the the trained and the saved model, one. Second, we need the environment file. Third, we need the scoring file. So like this, scoring file is the third thing. Score file. Score file is the one which is like which literally is a, you can say, can be a .py file. And what this .py file does is it takes the API. I'll just explain that. Give me 2 minutes. So one more will be there, scoring file. Then after this is when we can do the deployment of this image. So then when the deployment comes, you can deploy this, and now this is containerized. You can deploy it anywhere you want. Now, can I deploy this without even containerization? I can, sort of. We don't need all this, but for example, if I was doing some sort of dev and test, let's say I was testing it out, right? Then we will use ACI, Azure Container Instances. So that same machine learning image was used to create the container here. And now this container is running, and this is the score file. And the endpoint which you were talking about is this endpoint. So this endpoint, and what is this endpoint? This endpoint will be having the URL and the key over there by which authentication can be done of the API call. So and this endpoint is the one which is an information about this endpoint, like the URL key is what is listed in that endpoint section over there. All this. So now after that, so when the API call comes in like this. So what score file does, the data which we have in the API call, let's say this is the API call is having these attributes over there. So the score file basically loads this data into an array and will so it does two things. First of all, it will load the model. So this score file will load the model in RAM, load the model as well in memory as such. So that's one thing which it will do, load the model, initialize the model. Second thing which this file will do is the data which will come over the API call, it will put that into an array, and based on that array, it will do a model.predict on top of the array. So let's say model.predict as such. And whatever output comes out, you can beautify the output and then it throws it back like this. So the Y dash goes back. So the various deployment targets can be there, and they all have, you can say, uh, the various type of endpoints can be there. But the endpoints which we are referring to right now is this one, the API endpoint. This is the process which needs to happen after that. Think it through. Any questions, guys, in this? Right? The process is like this. I'll just summarize this over here. If I put a few numbers over there. So once your model has been trained, we will save it, right? Let's say put 1. Then second step is create the image out of it, container image. To create the container image, we need the trained model, which is already trained and saved with us. We need that, one. We also need the environment file, second, and we need the score file, 3 things. We'll create the image over here, the Docker image. Then this Docker image is the one which is deployed after that. So when it is deployed, it has to be deployed in some Azure service as such. So there are various Azure services like container instances, or we have one more called as Kubernetes, Azure Kubernetes services. So wherever we are deploying, that's not really of much concern right now. We can think it through. But when we deploy this, when this is deployed, the endpoints will be exposed or will be automatically exposed as such. This endpoint will be registered in the endpoint section. So all the information about the endpoints over there. Are they healthy, not healthy? Are they accessible? What is are they serviceable right now? What type of endpoint is it? All metadata about it. And the score file does 2 things. It loads the model as such, initialize the model. And secondly, whatever data comes over the API call, it does a model.predict on top of it and throws the output back. That's what it does. Okay, one more question is there. The accuracy is pretty high. Was it because of 2 classes, less number of examples? The accuracy was pretty high because of 2 reasons. First of all, we were using one pre-trained model. ResNet 50 is itself is a very you can say uh, not sure how to put it, powerful model which with having millions of parameters which are already pre-trained. And when you talk about images, so rocks are like, you're just think we are thinking like rocks are there, right? But if you think about images, we have textures, we have colors, we have the the shapes are there. So it already knows all of this. So and definitely you can say uh, we also trained it on our data. We also had enough amount of data. Because of all these reasons, we can say that the accuracy was pretty good. And 95 is not, we were getting 96, not 99, I think, 96. Okay, so think about it. Questions, please. Are these steps part of the document? Yes. The deployment steps are not there. That will be another document. The deployment part, rest will, everything will be there, whatever we have done. And join me for tomorrow's session. We will talk about, tomorrow is MLOps. So everything and anything and everything about model deployments, including endpoints, including retraining, including DevOps cycles and GitHub action-based cycles and Azure DevOps-based cycles. So the tomorrow's session will be of approximately 60 minutes. So we may not be able to cover everything there, but you will get the clear picture of what happens during the model deployment.
Any more questions, guys? You can even unmute your mics and ask the questions. Let's call for a wrap up then.
Right. Okay. So the learning link is there. The path, if you have the YouTube channel link, please put that in the chat again.
Yes.
So everybody, if you want to go through the previous sessions which I have done or anybody else has done, uh, you can just subscribe for the YouTube channel link of Reactor. The link will be in the chat in few minutes. And I'm also available on LinkedIn. My profiles are here. You can find me on LinkedIn. You can ask your questions later on as well, or we can discuss on technology itself. So you can find me there. Join us on the link in the LinkedIn group as well. The link is there in the chat. Find the upcoming Reactor session from the meetup page. I generally go one page back over here to see the list of the upcoming sessions over here, like this, like that. And find us on the do the learning module to cover the interesting things which we talked about today. Okay, so then I think we'll wind up in
You'll mind up. Yeah. Thank you, Shivam, for the amazing session. And thank you all
thank
for
you.
joining us today. Please do share your feedback about today's session. Also, feel free to use the Learn module link shared by Shivam in the chat section. This will give you the access to the additional resources to take your learning further. Also, please visit our Microsoft Reactor Bangalore meetup page for more upcoming sessions. Thank you all once again and enjoy the rest of the day.
Thank you, Parth. Thanks everyone. Have a nice day.
Thank you, Shivam.
Thank you.